Okay, today in this video we are going to talk about functions. So what is a relation first? A relation is a set of pairs of inputs and outputs values like this. This is the input here. So, and this is a output value. So this is a relation between an input and an output. So again, the relation is a set of pairs of input and output values like this. If I have here a set of pairs like this. So we have here three orders there in this relation. X values is the inputs and Y values is the outputs. So this is the inputs and this is the output. So here the input is 2, -3, and 0. And the output is 1, 4, and 5. Also, the X represents the domain and the Y represents the range. So when we come to the domain, it will be 2, -3, and 0. Then the range, it will be 1, 4, and 5. So this is a relation. This is a relation. Now we want to see how we can determine if this relation is a function or not. In order for the relation to be a function, it must have one condition, which is every input value must have only one output value. Again, every input value must have only one output value. If an input corresponds to 2 or more outputs, the relation will not be a function. Let's see here. Here is the inputs of this relation, right? 2, -3, and 0. 2 corresponds to 1, and -3 corresponds to 4, and 0 corresponds to 5. So each value in X corresponds to only value in Y, which means that each input corresponds to only one output. Then this is a function. Let's see here. This is the relation between the time of day and the temperature. Okay, let's see. 1 from the input corresponds to only one value. 2 corresponds to only one value. Like that for 3, 5, and 6. So is it a function or not? Yes, it's a function. That means we must say that the relation can or can't be a function, but the function must be a relation. Okay, so here, if we focused here on the values of X inputs, we can see that each value comes out of it only one arrow. One arrow, that means that it is corresponding to only one value. Let's take an example. Here the relation is written as a mapping between the domain and range. Let's see if the relation a function or not. Example 1. Here, focus your eyes on the domain. Focus your eyes on the domain. -2, 1 arrow. -1, 2 arrows. So stop here. It's not function. Okay, the other one, -2, 1 arrow. -1, 1 arrow. 0, 1, 2, all of them 1 arrow getting out of them. So this is a function. Here the same, the domain. So we concentrate on the domain to see it's a function or not. 1, 2, 3, 4, 5, all of them getting out of it 1 arrow. So this is a function. Going to the other one, from the first number, from the first input, -5 get out of it 2 arrows. So be smart. Do not look to the rest. This is not function. Okay. Now, if the given is as a table, if the given is as a table, do not waste your time. Only look at the input values. If it is repeated, so this is not a function. So concentrate on the inputs. If there is a value repeated in the inputs, means it may have two values corresponding in y, so it's not a function. So look at the inputs here: -2, -1, 0, 1, 2. Is there any value repeated? No. So this is a function. Okay, the second one: 0, 1, 2, 1, stop. There is here two values repeated, so not a function. Am I looking at the output? No. Okay, here 10, 7, 4, 7, 10. Error, it's repeated, so it's not a function. Here 0, 3, 9, 12, 15. Is there any repeated values? No. So this is a function. But here, stop. The 3 is repeated among the outputs. It doesn't matter. I'm not looking at the output. Never ever. Okay? Let's see another example. Here, if it is ordered pairs, I want to state whether it's a function or not. Okay, my eyes is concentrating on the domain or on the x-axis only. Here, 10, -2, -6, 5, 8, -11. Is there any values repeated? No. So this is a function. This is a function. Here, number 3, for example, -3, 7, -3. It's here repeated. Do not complete. For now, I can say it's not function. So you should be smart. Okay. Let's take this and an example. 6, -2, -6, 20. Here, is there any repeated? Can you say that 6 and -6 are repeated values? No, 6 and -6, two different numbers. So this will be a function. Do not get confused. Okay. Here, I want you to know that the same concept we are studying is the same. That how to state, again, I'm revising, how to state a relation is a function that if only each value in x only has one value at y, whatever the given is. Okay, here the given is a graph. Here the given is a graph. So what should I do? I should notice each value of x has only value of y. So I'm going to see this line. I'm going to draw a vertical line on each value of x. Here, this vertical line concerning negative here has only one value at y. Good. Here, only value at y. Only 1 point. Here, 2 points. So stop. Do not complete. It is not a function. Okay, going to example number 2. Here, only one value, vertical line. Only one value, another vertical line, only one value, like this. So make sure that you drew all the vertical lines on the x values to see it contains only one value of y or not. So this is, yes, a function. Okay, another example. Here, vertical line, only one value, vertical line, only one value, and so on till the end. So do I have to test all the values of x? Yes, you have to test all the values of x to see it contains two values of or more in y or only one value. Okay. Going here again, let's take this and as an example. Number 3, be smart from the beginning. Is it a function or not? You can notice from the beginning that 0 has 2 arrows getting out of it. So it is not a function. Here, number 5. Take a look on the domain, on the X inputs. All the values getting out of it, only 1 arrow. Means that all the values corresponding to only 1 value in Y per each value of X. So this is a function. Okay, here, the same table, but in a different way. So my eyes lies only on the X values. Is there any repeated values? No. So this is a function. Here. Is there any repeated values here in number 6? Negative 13, negative 3, 12, 17, negative 3, oops, error. So this is a repeated function, so repeated value, so this is a not function. Well, do I have another way? Yeah, here. State this graph represent a function or not. This must concentrate, you must concentrate here. We do here a test called vertical line test. Vertical line test. Draw a vertical line wherever you want. Draw a vertical line wherever you want and see. It will intersect with the relation in 1 point or 2 or more points. If it intersects with the relation in 1 point, so this relation is a function. If it intersects with it in 2 or more points, so this is not a function. Let's see. Here, I'm going to do what? I'm going to draw a vertical line here. It cuts or it intersects the relation in 2 points. This point and this point. Don't say this point. This is not the function. This is the x-axis. Okay? Doesn't matter with me. Only these 2 points. So this is not a function. Someone can tell me, I will draw the vertical line here and it cuts the relation in 1 point. Okay, but you must try all the positions. You must try all the positions. Okay, so this is not a function. Okay, back here to number 2. If I draw here a vertical line, it will cut it in only 1 point. Here, 1 point. Wherever you draw, it will cut it in 1 point. So this is a function. Here, vertical line, 1 point function. Here, if I draw like this a vertical line, it will cut in only 1 point. Here, 1 point. But take care, if I draw like this vertical line, it will be 2 points. So error, not a function. This, not a function, and so on. Okay? Here, if I draw here a vertical line, only 1 point. Here, only 1 point. But here, right on this line, it will be a lot of points. So this is not a function. Okay. If the relation is represented by an equation like this. Okay, let's see number 1. If I want to determine this is a function or not, I should isolate y. I should what? Isolate y. Come here. If I want to isolate y, this x will go to the other side by negative. So y squared equals 4 minus x squared. Then I want to get only y. So y will be equal positive or negative root 4 minus x squared. Positive or negative means that for only one x, I have two values at y, and this means it is not a function. So whenever I have y squared, means that I have two values for y, so this is not a function. So in number 2, here, y, it's power 1, so any value for x will be only one value for y, so this is a function. In number 3, the same. I'm looking at y, power 1, so this is a function. Okay, here, number 4 and number 5. They should be smart without trying anything. Do you remember which function or which relation it is? It is the equation of a circle. It is the equation of a circle. And a circle for sure is not function. Okay? I hope you enjoyed this video. Goodbye and see you in the next video.